So, everybody, welcome to Newton. My name is Rob Schultheis. I've been working here for 9 months as a QA engineer, and it's a real honor to get to talk to such a nice looking group. Thank you all for showing up. So, in the meetup, we talked about testing REST APIs, but I'm changing it. Now we're just going to talk about testing web services. Because I think, for those who may not know a whole lot about what web services are, REST is a term that describes a certain pattern of web service. Am I in this video camera? Yes. But generally, we just want to talk about web services in general. But the talk's really going to be about a lot more than that. So I think this is my 7th professional job doing testing, and that spans about 15 years. Some of that part-time, some of that contract, some of that just jobs like this where I'm working professionally, and I've seen a lot of different kinds of testing. I've seen a lot that works well, and I've seen a lot that works not so well. So I kind of want to share some of those experiences and lessons, and yeah, so what am I going to talk about? I'm going to talk about, A, how I got into Selenium testing, because this is the Selenium meetup. We got to talk about Selenium a little bit. I want to talk about some of the issues I had making heavy use of Selenium, and how I went about solving those issues. And how I did that was testing against web services. So I want to talk about why I think that works a little bit better than just making extremely heavy use of Selenium, having a more balanced approach with some Selenium tests, some web service tests. In order to explain that, we're going to talk just a little bit about what a web service is. I want to sort of take a quick deep dive into just exactly how do we create tests here at Newton, what tools we use. I've released an open source library called Grifter that I use to help me make tests. So I want to show you guys what Grifter is and how I use it, why I think it is nice. And that's pretty much the top. So some of the things I say might be a little bit controversial, maybe not. If anyone wants to make a comment, question, whatever, you're more than welcome to do so. And also, if you're just curious about what Newton is and what it is we do, you're welcome to come up to me after the talk. We also got a couple other nerds around. I see Sean over there. I see Christine, Sravan. Go grab a nerd and say, what the heck is Newton? What's this all about? It's kind of complicated, I'm not going to lie. All right, so what happened? About 4 years ago, I had never used Selenium. I had never really used much open source software. It's kind of coming from a more corporate, closed source background, Microsoft-based background. And I got this job at a company that made a website. The company was called Second Market. I showed up, they said, hey, we've got this big suite of Selenium tests. This was back when it was Selenium 1.0. There was no WebDriver. I said, we got this big suite of Selenium tests. It doesn't work so good. We want you to fix it. And I said, okay. Kind of started fixing it. It was pretty hard. It took me like a day and a half just to get the test to run on the computer they gave me. So that was a little bit of a rough intro to Selenium, but about a month into it, they said, all right, we're killing that old website, we're killing that old test suite, we want you to make new tests from scratch. Awesome. I get to make something from scratch. That's like tester's dream. And this was right about the time when Water was getting popular. Has anyone worked with Water? Yep. So Water was sort of an alternative to Selenium originally. It was for Ruby, had a really nice API, and it ended up sort of, the API got grifted into WebDriver, and WebDriver became Selenium 2.0. I used to know the difference between what WebDriver is and what Selenium 2.0 is. I think I forgot it. Nonetheless, water was out there, I started writing tests with this cool water thing, and the tests worked pretty good. It was simpler than Selenium 1.0, right? There's no jar file you have to start. Everyone was pretty happy, and I just kind of had this feeling. I was like, I've made a robot, and it's doing my job. And yeah, it was pretty sweet. The tests were working, and sure enough, the website, this brand new website with this brand new test suite, started getting a little more complicated, a little more features. Had to write more Selenium tests. And, you know, the developers were using unit testing and things like that, but we didn't really have another approach for testing the full stack, total integration testing. So I did what I knew. I started writing more water tests. About that time, WebDriver was getting popular. So I made these tests, WebDriver tests as well. So not only would they run IE, they would do Firefox and Chrome. Worked pretty good, and I felt like I had a robot army. Because you know what happened is the tests started going pretty slow, taking a long time to run end to end. So we used this, this grid technology, Selenium Grid. The suite started getting a little more complicated. We had to use the Selenium jar. There was no Sauce Labs at the time. We weren't using Sauce Labs. So, had this nice robot army. Everyone was still pretty happy. Test suite was giving us good feedback, catching bugs. And they said, hey Rob, guess what? We're making a mobile site. And I was like, oh no. So I kind of wrote some Selenium tests for the mobile site, and I was like, I have a cell phone using robot. This is awesome. But a week later, they said, oh, guess what? We're canceling the mobile site. So I never got too far into mobile testing. So I can't really speak too much about how you would use Selenium for mobile testing. But the website kept getting bigger, more features. I kept writing more tests for those features. And everything was working so good. Hey, I just went to the beach, started drinking drinks, content that my robot army was back there doing what needed to be done. So, this is sort of the progression of the Selenium suite so far. Is this a familiar trajectory to anyone, where start small, more tests come, everything's working good? Let me tell you what happened next. I was at the beach, drinking my drinks, not really. And the boss says, hey Rob, you know, what's going on with this test failure? This mic's kind of funny, isn't it? What's going on with this test failure? Well, it wasn't just one test failure. A couple tests were failing. Started digging around, fixing them. The site kept changing, more tests kept failing. In a lot of cases, these were the old timeout tests where Selenium's looking for an element and it's just taking its time to show up. It's not really legitimate failures of the test framework. In some cases, the website was changing too fast, and the tests weren't keeping up, and the developers weren't all that interested in getting involved in the test code because it was kind of complicated. So I spent a couple of months in this situation, and I started feeling like I was just pushing this Selenium rock up a hill. And it was kind of painful, and really needed to find a solution, right? We got too many tests, they take too long to run, they're too flaky. I have to sit there and kind of translate the failures for everyone else in the organization. We just can't rely on these tests. All right, does this situation feel familiar to anyone? Got a couple hands, and I know it does, because if you go to the Selenium conference, you read about Selenium on the internet, what you find are a lot of articles like, hey, how can you make your Selenium suite go faster? How can you make your Selenium suite less flaky? So we found our answer at this job, and the answer was testing against web services. Basically, our Selenium tests were the only full stack tests we had. Like I said, they were trying all kinds of positive cases for how to use the website. They were trying all kinds of negative cases. They were trying everything a user could do, should not do. You'd have to be crazy to try this. It was just too much. So what ended up happening was we sort of chopped out about 90% of the Selenium tests. And we just started running what we call happy path scenarios, where the test would sort of use the website correctly in these big features, and they would fail dramatically, but we made sure to make them very reliable. And the test kind of lagged the infrastructure. Now, what do we do with the other 90% of those test cases? We replaced them with tests against the web service, which ran faster. They weren't flaky at all. They were just extremely reliable. The developers found the framework a lot more comfortable. The framework itself was a lot simpler. The test code was a lot simpler. And that led to developers getting involved in the test case creation. And that was a huge win. So Selenium is a fantastic tool. It's made a lot of things possible, but I do think it is overused. So that's part of what my message is here today is, let's not use Selenium so much. Let's use it for sort of bigger things and make our tests as reliable as possible, but let's find ways to test that are more reliable, faster, and simpler. So how do you do that? This is where we're going to start getting into. How do you test against web services? This is what a Selenium test looks like. It's everything. We got our web browser, and we don't care how anything gets into that web browser. As long as it's there, our test is happy. Now, if you want to test against web services, you need to break this down a little bit. So, this is sort of one popular architecture for a website. You still got your browser, you still got your Selenium tests, but you got this web server up here that's serving content to the browser. And I've written JSON up there. JSON's a format, for those who don't know. And you got all this static content coming from a content distribution network, HTML, CSS, JSS. That's a pretty standard piece of software right there. We don't need to heavily test what's going on here. We really want to test here. This is where all the really important logic is. Can this user do this thing they're trying to do? Can this user store this piece of data? Did that piece of data get stored correctly? These are the things your app cannot mess up. So let's just test right against it. Let's simulate a web browser, but we're not actually a web browser. Sometimes the architecture is a little more complicated. This is probably more the normal case these days, where you have multiple web services interacting with the browser. Some of those web services may not even be part of your company. Like if you have a like button for Facebook on your web page, that's going to Facebook, not to your company's website, web service, whatever it is. But again, you can still use tests to test all your web services together. You can have one test make a call to one web service, make another call to another web service, do some assertion somewhere in there. And we still got our Selenium test down here just telling us, hey, everything's working. Everything came up. But it's not exercising every single test case you might want to have. So understanding this architecture is really important in testing web services. It's also very important that you have this architecture, and a lot of shops don't. Now, most new websites are getting made in a fashion like this, but a lot of older websites are not. And that's part of our job as testers, is to say, well, if we build things in this way, we can do a lot more testing, a lot faster, a lot more reliably. So I find one situation I've encountered is where sort of we as QA just sort of accept what developers give us. Oh, well, this is how it works, that's how I have to test it. But we need to push back on that sometimes and say, look, I can make a lot better tests for you if you just change things in this way. So one example is, at Second Market, we had a lot of logic in the client side, and it made it really hard to test that logic. And so I had to advocate for pushing a lot of this logic into the web service. And some of that logic is things like, well, does this button show up for an admin? Does this user who submits this form, are they allowed to store that kind of form? It's just a really bad place to have that logic, because sort of bad users could figure out how to actually send those requests, even though the form is not on their website that they're looking at. So that's sort of that point, is that we really need to advocate for testable design. And I think web services are a great way to make testable design and testable architecture. So here I am droning on about web service. What is a web service? Well, I can't really show you one, it's a piece of software. But I can show you what they do. So I imagine this is pretty familiar to a lot of people in the crowd, but maybe some of you haven't actually interacted with web service in any depth. So what we've got here is what a web service does. Up top, it takes a request. Down below, delivers a response. The request consists of a method, in this case it's post, and an endpoint, in this case these are learning instances. Now this is a real endpoint in the Newton API. Below that, we have a set of headers, and we have a request body. Excuse me. The request body has a name and a graph ID thing. Now this is JSON, the curly braces. This is all HTTP specification. Excuse me. We send this in, we get a response back, we get a response code, in this case 201, we get a bunch of response headers, we get a response body. And this response body looks a lot like a request body, but there's been an ID added and an in progress field added. So does anyone know what this request is doing? Who's not a nerd? Nerds are people who work at Newton, by the way. Okay, so this request is making a learning instance. And posts are often used to create things. Now, a learning instance, like I said, is a certain kind of thing at Newton. We have similar endpoints for making users, for making all the various things that Newton sort of has in our database, which you would need to know a lot about Newton for that to make sense. Okay, so everything we're looking at here is important from a testing perspective. If we're going to test a web service, we need to be able to control what we're doing, whether we're posting, what endpoint we're posting to. We need to control all these headers, we need to control this body, and when we get our responses back, we need to sort of assert on maybe what the response code is, maybe what these headers are, maybe what this response body has. And that's the anatomy of a web service test. Now we might make many requests in combination with many assertions, but what we don't have here is any sort of funky user interface elements that can change around and make our test hard to make reliable. Everything here is very easy to assert on. And this happens in a typical web request, 100 milliseconds. So if this were one test, it's going to take 1/10 of a second to run. Whereas if I had a web app where I was creating these learning instances, I would have to start the browser, go to the page where I can make it, fill out the form, hit submit, see that something came back. It's going to take a lot longer to run. So that's what a web service is. I want to show you guys now how we test this. So there's probably 1,000 different ways you could make tests against web services. All you need is a way to send HTTP requests. Every language in popular use has a way to send HTTP requests. Most of them have several. So what I've chosen is to use the Ruby programming language, the RSpec testing framework, and this library called Grifter that I wrote. But before we get into Grifter, I want to show you what a test case for this request would look like without using Grifter. So this is some code. It's Ruby code. It's an RSpec test. Have people used RSpec here? Excellent. So for those who haven't, you have describe. Describe groups together a group of test cases, and then you have it. It can be thought of as a test case. Now RSpec calls it an example, but example essentially means test case. What we're going to do in order to test our endpoint is we're going to open up an HTTP connection. We're going to set up some headers. We're going to set up our post body. We're going to execute the post. Now that is going to return a response object. Out of that response object, we have to get the body. We have to JSON parse it. Remember, our response comes back in the JSON format. That gives us our body. Now we're ready to do our assertions. We can say we should have gotten 201 back, and that response should have had a key ID added to it. So this is good, but it's kind of naive, as I'm sure you can see, because a lot of things are hard-coded. So any framework, you want to find ways to sort of move all this boilerplate stuff out of the way. So I'm going to run this for you, but I remembered I have to do a very quick thing before I'm able to run it. But I'm not going to do that quick thing because I want to show you what it looks like when it fails. So in order to run, we're just going to run the RSpec command. I've typed out that test case into this thing called plain spec. So this is sort of a normal naming convention for RSpec tests. Gonna hit enter. It failed. Uh-oh. We don't see a lot going on here. But I knew it would fail. And the reason that this test case is failing is because we've got this hard-coded bearer token here in our headers. Now, bearer tokens are, in our API, how we know who you are. You have to go through an authentication process in order to get a bearer token. So I don't want to get into a lot of depth, but the basic idea is when you get one, it's good for about an hour, and then it's no good. And that's what's happened to our test case. But what I do want to call attention to is that we don't really see much here. The way we've coded this test is not helping us understand what is going back and forth from our test to the API, what we're getting back. Okay, this is the same test case, but it's written with this library called Grifter. Again, we have our describe, we have our it. Now this time, instead of hard coding our bearer token, we have this nice method called setAccount. So at Newton, we don't really have users, or at least we don't call them that, we have accounts. So what this is essentially going to do is get that bearer token for us. Now, instead of saying, oh, go make a post to /learning instances, we just say create learning instance. We're passing in a graph ID. That's still hard-coded. That's still a bit of a problem. We get a response object. Now, we're not doing any JSON parsing. That's done behind the scenes. We're saying I should have got a 201 back, and my response should have key ID. So whether or not you use Grifter, I think what we all should strive for is expressive test cases that read well. And that's what I've tried to optimize Grifter for, is expressiveness. I really want this to sort of read like English, and kind of sort of getting there. It's easy to take that too far. So you don't want You could do something like Cucumber. Has anyone used Cucumber? I know a couple of folks have. Cucumber essentially write these statements in English, very similar to RSpec in a lot of ways, but then there is this process of translating those English statements of post to learning instances into Ruby code that probably looks a lot like this. And that's really nice if you need that level of expressiveness. Here at Newton, I don't need it because pretty much everyone who works here is pretty technical. We don't have to show these to a lot of business-facing people. Okay, so now I'm going to run our grifter test case, and we'll see a little bit of a difference in how this runs. Here we go. Okay, well this one passed because we have a good bearer token. We get to see the post to learning instances, all the headers I'm sending in. We get to see our response code, all the headers I get back in our response body. Now there is an option to turn this logging off, but I recommend you don't. I found a lot of bugs just by reading this. In fact, most bugs I find, I don't find because I wrote a test case looking for some specific thing, like, oh, the response should have an ID key. It's no. That test passes, but I'm reading this log and I say, oh, you know what? This location header is totally wrong. I can just see it by looking at it. And this is sort of a way to approach exploratory testing with web services, which is really important. If you're using a web app, and maybe all you're doing is running Selenium tests, but in a lot of cases you can still watch the browser come up, see it go through it, and your eye can pick out things that are wrong that the test is not going to pick out. If you're writing tests against web services, you need to build that, and it's really, really important. We need to give our brains a chance to pick the inconsistencies out that pop up in front of us. So that's a big part of what Grifter does, is just log things in a consistent way. That once your eye gets used to it, is you can say, okay, I can see what's going on with my web service. So this is literally how we've written our tests at Newton. Now, what's next? I want to talk about how we use our tests. So what I've encountered is that a lot of times we as testers think about how to make tests. We don't spend a lot of time thinking about how to use tests. And I think that's a problem. Has anyone had an experience where a developer says, hey, I've got this change, can you run your tests? Happens every day, right? Well, I don't like that. So what I would say is, let me show you how to run them. So RSpec integrates with Jenkins very nicely. Now, if you don't know what Jenkins is, it's a continuous integration system. There's a lot of things like it. There's Bamboo, there's other CI systems. But it's very important that we build our test suites into our CI system. And here at Newton, that's Jenkins. And why is that important? The developer says, hey, can you run your tests? Yes, you can. You deploy your change to QA. Let's just pick QA from this list, and away you go. You're running tests. We can also see reports here. So this was the last report to run. In the upper right, we have 538 tests. Everything passed. How nice. Now, if something should fail, this turns red. You get a assertion message, which I try and make the assertion message as good as possible. RSpec does a lot of that for you. So this report is one of my favorite features of RSpec. A lot of times people say, hey, what's tested? Well, here's what's tested. Here's what was tested the last time. Having this in Jenkins is very important. I would say that this is an atomic thing that everyone should do with any test suite that gets made, if it's meant to be sort of run on a regular basis. Now maybe you have tests that are sort of ad hoc tests and they're very special for this or that. Don't need to put those in Jenkins, but any test you use to assure the quality of your product on a regular basis, build it into your CI. Why? Not just so you can tell the developer, hey, go press the play button yourself, but so that you can start using it in more complicated ways. So what I want to do is take this plan and use it on an event-driven basis. So a developer pushes code to a repository, a build gets made, gets deployed to an environment, tests get run, and if anything fails, the failure report gets emailed out to the developer who made the change. We don't have that working yet, but we're working on it. Now that we have the test in Jenkins, we can do that kind of thing. And we've got other kinds of test suites. So this plan is something that runs once an hour against an environment we want to keep working, and occasionally it fails. Developers get the notice, they go fix the environment. So this is alerts, but it's a very deep form of alerting that basically exercises a very complex task. Using our API that sort of touches all the back end, and if any part of that back end breaks, the test fails, and we go fix it. So, build your test into Jenkins, that's the motto there. So what else? Now, this Grifter library, I'd love for people to try it out if they're thinking about testing web services. So let me ask a question, who has tests against web services right now? A couple people, I'm happy to see that. Now if you don't, and you want to try this out, you can go to GitHub and check out this Grifter library. It's got no stars, I want some stars on it. Now there's other competitors for this, so of course there's lots of ways to go about making HTTP requests. So I want to dig into just what Grifter is. I think it's got some nice features that go beyond testing that can add value to your organization. So that's what we're going to do now. So here's this test case we were looking at. Now you might be saying, okay, what the heck is create learning instance? Where does that come from? Well, that's a method that I call a grift. So let's take a look at it. Doesn't want to do full screen. These colors are pretty bad, aren't they? Well, I don't know if you're going to be able to see this, but up there we've got create learning instance. Now this is the whole file. Once again, I've been striving for expressiveness and just ease of reading, ease of maintenance, because I really want everyone to get involved in this. So, how does create learning instance work? Well, first we say a little bit of log. Hey, I'm going to go create a learning instance, and then we have this CAPI. What is CAPI? It's the Newton API. We're going to call post. We give it an endpoint. From there, there's this. The next thing you pass in is the body, and into that body, we're going to merge some overrides, which get passed in. You don't have to. And this is all just sort of sucked up through this a convention, so that it's available in your test code without you having to do any special configuration or anything. Once you get Grifter set up initially, so you can add these kind of methods to your heart's content. You can see that there's another method called getLearningInstance right here, which I'm going to demo. Now, getLearningInstance does a get against the Newton API, and it requires an ID. So, I think I know where to get an ID because we just made one. Here's an ID. So I want to show you another feature of Grifter. So I'll get this command to the top here in a second. What I'm doing is I'm running a command off the command line called grift. I'm giving it a -e argument, which says, what environment do I want to go in? We have QA, dev, production. We've got all those environments. In this case, I ran this test against QA. Okay, it got our learning instance. Now this is not a test. This is just some useful stuff that, again, helps you do exploratory testing. So let's say you've got your test, you start like this, it's working, and then you extrapolate a lot of this boilerplate out and you get a nice thing set up. What's really nice is if you can use all that code in other ways that are not tests to interact with your API. So one thing that's happened at the past 3 jobs that I've worked at, including this one, is people have said, hey Rob, you've got all those scripts and things that interact with our API. Well, we have this thing and we need you to interact with the API. And one example is a client had mailed in a spreadsheet, and it was in this sort of format that was specific to that client, and they needed to get it all into the back end. And well, we could write a sort of spreadsheet importer in Java, but maybe we can just sort of make a quick script that'll parse out the CSV and make the calls to the API to get that data imported. So I ended up reusing a lot of my test code to make the spreadsheet importer. Took about an hour, and everyone was super happy. So what Grifter really is a DSL for interacting with APIs. DSL is a domain-specific language. So you can sort of express what you're doing with a word and abstract away a lot of the complexity of where do I post, what sort of keys are required. So just being able to call sort of endpoints off the command line might be useful in some cases. But what's really nice is if you can write scripts. Okay, so this is a grift script. I wonder if I can make this brighter. It's probably not going to do anything. I don't know how to use projectors. But what we're going to do now is make 5 learning instances. We have a simple root loop. 5 times do create learning instance. That line above, graph ID equals get test data. That's sort of a fancy way we have of not hard coding data. And I'm happy to talk about that in more depth if anyone's interested. But it's a little beyond the scope of what we're into here. Okay, again, we're going to run it. And maybe the people in the back. I'm going to rerun this with the thing at the top. Okay, we're calling the grift command line. We're saying do it against QA. And now I want you to run a file. That's what -f means. 5 learning instances. On the end, -v means do so verbosely. I want to see everything. And there we go. We made 5 learning instances. So these grift scripts are how I've accomplished a lot of the ad hoc sort of tasks that involve the API that are not necessarily testing. It's also how I investigate the API. It's how I manually test it. So that's sort of a point I want to make is let's not forget about manual testing. That's how I find pretty much all my bugs. The tests just tell me that things are still working. Okay. Now there was another point I wanted to make. What was it? Does anyone have any questions about any of this? So, here's some of the wins that have happened when we started emphasizing testing against the web services. We've we've got a lot more tests that cover a lot more features. We're a lot more sure that our product is not going to break down in all the important ways. Meaning it's not going to let bad data in. It's not going to let someone do something they should not be allowed to do. And on the other hand, everyone who should be allowed to do things will be allowed to do them. We've got all those cases covered. The tests run very fast. They're very reliable, by and large, and I think the best win has been that I have had developers come up to me and say, help me write these test cases. Can you help me understand how this works? I have a test case I want to write. That never happened when I had a big complicated Selenium suite. So I'm just going to close up with some notes about Newton and what our API is. So here at Newton, we don't really have a website at the moment. We're starting to think about making some websites, and when we do get around to making those websites, Selenium is going to play a part in testing them. But I am going to advocate for sort of architecting the website and the web app in a way that makes it so, again, we can test all the important parts through web services. But what we do have here at Newton is a public-facing API, and it's been my job to test it. So when I started here, there were a couple tests against the API, and I said, I want to try this experiment where I use some of these techniques I've been developing in the past 2 jobs to sort of architect a generalized approach to testing web services, and that's gone on to become Grifter. But what is this API? It's an API that helps us personalize the educational experience for all the students in all the world, starting with the US. If you want to know more about it than that, I'm going to have to request you come up to me or one of my fellow nerds. Yeah, so that's testing web services. Any questions? Comments, complaints?
So does that only apply to REST APIs?
Right. You can use this for REST to your heart's content. Now the only reason I haven't sort of used that word a lot in this talk is because REST is a pattern for a web service. There are other ways to sort of structure your endpoint. So what does REST say? It says if you have a resource like a learning instance, it should have a post, it should have a get, it should have a put, it should have a delete. And REST sort of dictates how you structure those endpoints. But there are reasons to break that structure. And one example here at Newton is we have an API for delivering analytics. It's really a reporting API, and it's just a bunch of gets with sort of big endpoints. It's not a REST, it doesn't follow the REST paradigm. But to answer your question, yes, you can use this for REST to your heart's content. Yeah.
You design your test cases by looking at the API documentation, or do you look at the actual code?
Good question. How do we design? I design my test cases by divining the truth of how things should behave from the great infinite beyond. Some of that involves reading documentation. A lot of times, I don't like to trust documentation. So documentation might say, oh, you should have an endpoint and it should do this, and I'll read that and I'll say, well, no, it shouldn't, and we shouldn't have that endpoint. We should have this other thing that should do this other thing. So I'll go to the documentation writer and say, I really think it should work in this particular way. So a lot of it is from working with developers to understand what they've already implemented. My favorite way to design test cases is to do so before the feature is written. And this is a wonderful thing about testing against web services when you compare it to testing against Selenium. It's really hard to say, I want to log in as this user, go here, I should see these words, go here, click this button, I should see this, before that feature exists. With a web service, you can say, I should have an endpoint that takes a body with a name and a graph ID, and it should return a 201 when I post to it. So if you can get out in front of your developers that way, And even better, get your developers writing those tests before they exist. You're in a much better place than if you're following developers. And that way, test case design becomes product design at the same time. It's a hard thing to do, I'll say that.
How do you approach data-driven testing implementation?
So the question is how to approach data-driven testing, and sort of ask a question back. By that, do you mean sort of having some data like, oh, we have this user, maybe this learning instance, this graph, and running a bunch of test cases that sort of are generated off that data?
Yeah, I mean, you have your container capacity, your IDS, testing different parameters, your valid, alpha.
So I use RSpec, and I will dynamically code tests. So let's go back. Here is a statically coded test. This describe and this it are just there, but you can wrap these its up into logic. And that logic might come from, let's say I have a list of graph IDs. And I can say I want to run this test case for all these graph IDs and make sure I can create a learning instance with all those graph IDs. So I could say something like list.each do it. And in that way, I'll get one test case for every graph in that list. One example that's coming to mind is, again, going back to our analytics API, we have, at one time it was 40 endpoints on this thing, 40 different kinds of analytics you could ask for. But each of those endpoints needed to do roughly the same thing. It needed to allow an admin to access it. It needed to disallow other roles from accessing it. It needed to return certain status codes. It always needed to return JSON. And that JSON always needed to have a certain structure to it. So I don't know if this qualifies as data-driven testing, but what I did is I made a big list of all the endpoints this thing had, and off that list generated a bunch of test cases. And that ran something like over 1,000 test cases in about 2 minutes, and sort of exercised all the basics. And it didn't tell us, oh, this thing is reporting the analytics we actually want you to report. It told us that this endpoint's allowed to be used by certain users. So I think that's about as specific as I can get in this case.
All your requests for explanation, what would change in your test scenarios or your framework around information?
What would change if we had to not use HTTP, but use HTTPS? Essentially nothing. In fact, these test cases are HTTPS. Didn't exactly understand what you were saying, so. Oh, this config file is so hard to read.
Well, let me rephrase the question. Let's say you want to test that you are validating the right certificates, right? That's one of the tests. Now you see why I said that. So right now, what I see is you doing you just doing an HTTP request. But when it comes to testing a secure web service, you want to see whether the person who is actually asking for it has the right key or not. I mean, there's all ones is SSL, like negotiation, hashing, whatever. You want to test that. You want to implement that.
How do you make sure you have the right certificate? Now, I might be misunderstanding your question. So you can control the certificate authorities that Ruby uses to say that the SSL connection is valid. You can tell Ruby to not check SSL certs. But what you're really saying is you want to check SSL certs, and you can configure it to use certain certificate authorities or not. I have not done that. I think that's an interesting idea. But maybe what you're actually asking is how do you make sure that sort of things around authentication and authorization. And the answer is very carefully. So in our API, we use the OAuth specification to authenticate a user. And OAuth is complicated. In our test that we were looking at, we have to get a bearer token. And in order to obtain that bearer token, you have to make at least 2 requests. And you have to pass in a username and password. So I test those endpoints in the same way that I've sort of demonstrated, and I'll be glad to show you some of that code. But basically, you have a test that says I make a call to this endpoint with a bad username, I make a call to this endpoint with a bad password. Does it return the correct error code? Does it return a good error message saying, sorry, don't know who you are? Then you also try things like, let's put in an invalid bearer token and try and make this request, something that was not gotten from the API. So that goes back to being able to control the headers that your requests are being sent with. So however you're testing a web service, you need to control the headers. It's sort of part of the answer. And Grifter provides that way. If you want to set your authorization header to a certain value, or any header for that matter, you can do so. It might not read so nice, but as long as that's sort of in the context of the test, then that's how it needs to read. So,
have you tried a combination of web service testing and Selenium, like maybe create data say using your web services and say verifying with Selenium?
Great question. Can this be combined with Selenium testing? Yes, it can. I have not done so here because we don't really have many websites. However, I did this at a previous job and it worked fantastically. And the way it worked is that it would use a script like these Griff scripts that are not tests. They just make API calls, set up lots of data, and then I would fire up the web app and I'd say, let's go to this page that has this specific combination of data. Let's go to this next page that has a slightly different combination of data. Let's go to this page that has another slightly different combination of data. So there are so many ways to use it. And now this is Ruby. A lot of Selenium tests are also written in Ruby. So you could literally use Grifter in setups for Selenium tests where you build out whatever data you need, make sure the data is there. All you have to do is go to the page and check it. You could probably do even fancier things, like if you want to get around having to sign the user in, you could probably put a special test endpoint in your web app and say, give me a pre-authenticated user token, set a cookie in your browser, and then just start the browser up and you're authenticated. No need to type in username and password. You can speed your Selenium tests up, make them more reliable. I highly recommend it, definitely. Thank you guys so much. Stick around, finish up the pizza. You guys did a bad job staying in front of the camera.